Everything we understand about the universe, from the tiniest atom to the biggest galaxy, it all boils down to one simple thing: our ability to measure it. Today, we're diving into the fundamental language of science, physical quantities, and the incredible story of how we all agreed on how to speak it. So let's kick things off with a real head-scratcher. What on earth could the speed of light possibly have in common with a kilogram? It sounds like the start of a bad joke, right? But stick with me, because by the end of this, the answer is going to reveal a quiet revolution that completely reshaped the very foundations of science. All right, to get started, we have to ask a really basic question. How does science even decide what it can and can't study? Well, it all comes down to one simple, powerful idea: measurability. Here's the deal in physics. If you can't measure something, it's pretty much outside the field of study. A physical quantity is just any feature of an object or a phenomenon that we can slap a number on. If you can't measure it, it's not physics. Simple as that. And this is really where the line gets drawn in the sand. We can all agree on the length of a car or the mass of a rock, because those are physical quantities. But how would you measure beauty or likability? Sure, those things are incredibly important in life, but they're subjective. They're not the objective, measurable properties that physics can actually work with. So, once we've established what we can measure, the next giant challenge is how. And to do that, the entire world needed to agree on a single shared language. Here's the key idea. Every single measurement you ever make is really just an act of comparison. You're comparing the thing you want to measure against some agreed-upon standard, a benchmark that we all say equals 1, and we call that standard a unit of measure. Now, getting the whole world to agree wasn't easy. It was a long journey. Things got official back in 1875 with a central authority, the BPM, in France. Then, in 1889, the first real international standard was born, the MKS system, for meter, kilogram, and second. But as you can see from that timeline, the journey was far from over. Something huge was about to happen in 2019. So that original system of just 3 units eventually grew. It had to, leading to what we now call the 7 fundamental quantities. You can think of these as the 7 pillars holding up our entire system of measurement. And here they are. You've got the original big 3: mass, length, and time. But to describe more of the universe, we needed to measure electricity, so we added the ampere. For thermodynamics, we needed the Kelvin. For chemistry, the mole. And to measure light itself, the candela. But there was a deep, hidden flaw in this beautiful system, a problem that was threatening the very foundation of science. And it was centered on one of our most basic units of all, the kilogram. For over a century, the definition of 1 kilogram wasn't an idea. It was an actual object, a specific cylinder made of platinum and iridium, kept under 3 glass jars in a vault in France. It was called the International Prototype Kilogram, and by definition, its mass was exactly 1 kilogram. Every other kilogram on planet Earth was just a copy of it. And here's where it gets wild. Over the decades, when scientists would carefully compare the prototype to its official copies, they found something terrifying. Its mass was changing. The one object that was supposed to be the unchanging standard for the entire world was, itself, unstable. I mean, this posed a massive problem, both practically and philosophically. If your ultimate standard can change, what does that mean for every measurement, every experiment, every calculation ever based on it? The whole system was built on quicksand. So, scientists came up with a radical and, frankly, beautiful solution. They thought, instead of relying on a decaying chunk of metal, why don't we tie our measurements to the universe itself, to the fundamental, unchanging constants of nature? And in May of 2019, that's exactly what they did. In what was probably the biggest revolution in measurement since the French Revolution, the global scientific community officially adopted a completely new system. They changed all the rules. Just look at the change for the kilogram. It went from being defined by that one lump of metal to being defined by something called Planck's constant, a tiny, unchangeable number from quantum mechanics that basically describes the fabric of reality. This kind of thing had actually happened before with the meter. It used to be the length of a specific platinum iridium bar. Now it's defined by how far light travels in a vacuum in a tiny fraction of a second. Why? Because the speed of light is a universal constant. It's the same everywhere for all time. This revolution just swept through the whole system. The second got tied to the incredibly reliable ticking of a cesium atom. The ampere was redefined by the fundamental charge of a single electron. The Kelvin, our measure of temperature, got anchored to the Boltzmann constant. All of our basic units are now tied directly to the unchangeable laws of nature. Which brings us all the way back to our first question. What did the speed of light and a kilogram have in common? Well, now they're both defined not by fragile man-made objects, but by the fundamental, unshakable constants of the universe itself. So why is this so important? It means that a scientist in a future colony on Mars can calibrate her instruments to the exact same standard as a lab on Earth today. It means the foundation of science is no longer local and fragile, but universal and permanent. It's a stable bedrock to build the next centuries of discovery on. This new system is an absolutely incredible achievement, but it leaves us with one last thought. Have we finally reached the end of the road for measurement? Are these definitions now perfect and final? Or is this just another step in an endless scientific quest for absolute precision?